There's a very simple relationship between many of the fundamental ideas of the unit circle that was never directly explained to me in my algebra class, but it reveals where the seemingly arbitrary sine and cosine values that you have to memorize come from. See, the unit circle is inherently related to the trig identity sine squared plus cosine squared equals 1. But this is really just Pythagorean's theorem in disguise. Sine and cosine are just the leg lengths of all these right triangles that have a hypotenuse of 1. The pairs of numbers you memorize are just the leg lengths of two specific triangles. The first triangle has both side lengths as square root of 2 over 2. And the second triangle has side lengths of square root of 3 over 2 and 1/2. This triangle is actually repeated twice, once just positioned differently. And now the signs, the positive and negative signs that is, of each value will change depending on what quadrant you're in. But the actual numbers themselves will stay the same. And this is stuff that you probably already know. But now, let's just bring back that trig identity. See, we have this formula, and we have values to plug into the formula, but have you ever actually plugged them into the formula? What you get, at least in my opinion, is one of the most uneventful yet intriguing math reveals of all time. Are you ready for it? Here it comes. Look, this is just kindergarten math. But see, that's the beauty in it. It's the fact that these scary numbers are actually just the square roots of these innocuous fractions, which all comes about from its relationship to Pythagorean's theorem. They're just the a and b values for a squared plus b squared. Isn't that really cool? I think so, at least. And there's plenty of other little rabbit holes you can go down with the unit circle. Like maybe you realize that square root of 2 over 2 can be reduced even farther. Or maybe you start to think to yourself, why the word unit is in the name unit circle. But I'll get you started on another one. You've actually seen these triangles before. Maybe just not with their angles and radians. They're just your 30-60-90 and 45-45-90 triangles. If you remember your side length rules, which I know you don't, so here they are, would you think that sine and cosine will still work for these rules? I'll let you try that out yourself.